regarding cosmology, physical and modern aspects is the fifth in a series of voice recording videos or podcasts narrated by me, J.P. Seet. This recording was made in Guilherand-Granges, Ardèche department, southeast France, on March the 19th, 2024. Introduction. In the timeline of cosmology since Einstein's 1915 work, for me, modern cosmology may well begin after the period 1970 to 1984, when three classic gravitation, cosmology, and general relativity physics books were published. They were, firstly, Gravitation by Misner, Thorne and Wheeler, published in 1970. It is nicknamed the telephone book because of its size and denseness. Secondly, Gravitation and Cosmology, Principles and Applications of the General Theory of Relativity by Weinberg. It was published in 1972. Thirdly, Robert M. Wald's book from 1984 called General Relativity, which I nickname the Beige Physics Book because that's the colour, at least, of the paperback version I have. Now a quote from the Wikipedia article entitled Cosmology. Quote, "Physical cosmology is the branch of physics and astrophysics that deals with the study of the physical origins and evolution of the universe. It also includes the study of the nature of the universe on a large scale." End of quote. Einstein's efforts in the 1910s contributed to physical cosmology. His initially essentially static view of the universe was complemented in parallel by dynamic models where the universe was expanding. A quote from cosmoversetensions.eu. Einstein's general relativity was introduced in 1915, and like many other physical theories or models, it is described by an equation. Einstein's equation takes the matter and energy distribution as an input, and its solutions determine the space-time curvature which is caused as a result of the gravitational pull of the matter and energy inside the space-time volume. End of the paraphrased quote. American astronomer Edwin Hubble observed in 1924 that there were galaxies outside our own Milky Way galaxy. At the time they were only known as nebulae. Wirtz had coined the term redshift for the modification of the spectra due to the recessional speed of the galaxies. A longish quote from Wikipedia is as follows. Hubble went on to estimate the distances to 24 extragalactic nebulae using a variety of methods. In 1929, Hubble examined the relationship between these distances and their radial velocities as determined from their redshifts, combining his distances with measurements of the redshifts of the galaxies by Vesto-Slipher and by Hubble's assistant Milton L. Humason. He found a roughly linear relationship between the distances of the galaxies and their radial velocities, corrected for solar motion, a discovery that later became known as Hubble's law. Hence, in parallel, it was discovered that the universe is not static, but expanding. There follow some long quotes from the Wikipedia article about redshift. In physics, a redshift is an increase in the wavelength and corresponding decrease in the frequency and photon energy of electromagnetic radiation, such as light. The opposite change, a decrease in wavelength and increase in frequency and energy, is known as a blue shift or negative redshift. The terms derive from the colours red and blue, which form the extremes of the visible light spectrum. All sufficiently distant light sources show cosmological redshift corresponding to recession speeds proportional to their distances from Earth, a fact known as Hubble's law that implies the universe is expanding. In the earlier part of the 20th century, American astronomer Vesto Slipher, Wirtz, and others made the first measurements of the redshifts and blue shifts of galaxies beyond the Milky Way. The redshifts of galaxies include a component related to recessional velocity from expansion of the universe and a component related to peculiar motion, Doppler shift. Another quote from cosmoverse-tensions.eu. Dark matter is an essential component of the standard model of cosmology. Without it, we cannot explain how galaxies form and how the universe looks as it does today. Despite its necessity, we really have no real idea about what it really is. There is plenty of room for new and exotic physics here, which makes it the most intriguing component of the dark sector. The absence of any direct measurements suggests dark matter interactions with other particles and forces other than gravity must be very weak. Assuming this is the case, then we are left with dark matter models that only influence things distinctively by means of their mass. End of quote. In 1998, using observations of supernovae, Saul Perlmutter and Adam Rees independently found that the expansion of the universe is accelerating, for which they, along with Brian Schmidt, later received a Nobel Prize. About dark energy. There follows a quote from the site of the Kavli Institute for Particle Astrophysics and Cosmology at Stanford University in California. Fred Kavli was a Norwegian-American entrepreneur and philanthropist. Quote, "Our universe is expanding at an accelerating rate. This acceleration is driven by dark energy, which makes up 70% of the contents of our universe, and whose nature remains mysterious. By measuring the growth of cosmic structure and the universe's expansion history, sky surveys test whether dark energy changed its behavior during the history of the universe." End of quote. JP signing off now. Have a good day. Cheers.